Hi, my name is Zarifah Baria.
Hi, my name is Nurul Shafika.
Hi, my name is Nurul Iza.
Hi, my name is Nor Shafira.
So, what is radiation? Radiation can be described as energy or particles from a source that travel through space or other medium. Light, heat, and the microwave and radio waves used for wireless communication are all forms of radiation. It also includes particles and electromagnetic waves that are emitted by some materials and carry energy. Besides that, it can also be known as ionizing radiation. Some of the examples of ionizing radiation are X-rays, gamma ray, alpha particle, beta particle, and neutrons. A person cannot feel radiation, but radiation is easily detected and measured, and the exposure can also be easily monitored.
Okay, I would like to present to you about the heat from sun to the earth. Radiant energy waves that travel from the sun through space and become heat energy when absorbed by a substance or material. For example, electromagnetic radiant energy. Electromagnetic radiant energy is the main source of heat transfer energy on Earth. Most of electromagnetic radiant energy comes from the sun, which is 93 miles away from Earth. As acknowledged that Earth is the fourth planet that nearest to the sun. Besides that, radiation is different from conduction and convection because the radiant energy travels from the sun through space in the form of invisible wave rather than transferring heat from molecule to molecule. For example, when a solid object like Earth absorbs radiant energy wave, the energy becomes heat. The darker and more opaque the material are the absorbed wave of radiant energy, the faster the molecules of the main material move and the hotter they become. Furthermore, much of the heat from sun's radiant energy is transferred back to atmosphere. For example, we can see that Earth is much cooler than the sun because heat energy absorbed by Earth radiated back into the atmosphere. In the meantime, the electromagnetic radiation that was not absorbed by the atmosphere proceeds to the Earth's surface and heat it up. Some of the heat stays there, while the rest is re-emitted. Upon reaching the atmosphere, part of it gets absorbed and part of it passes through.
The color and surface of an object is really important when it comes to how infrared radiation is absorbed and emitted. For example, if you're wearing a black shirt on a hot day, infrared radiation in sunlight will absorb very well by the black surface and you will warm up quickly. Black surface is also very good emitter of infrared radiation once the object has become warm. On the other hand, light shiny surface are poor absorbers and poor emitters of infrared radiation. They were also good reflectors. In hot country, the houses are often painted in white or light colors. This is to keep the house cool as the white surface are poor absorber and good reflector of heat radiation. Another example is a shiny teapot. The light surface of the teapot is a poor emitter of infrared, so the teapot stays hot for longer. Sometimes we need objects to lose their heat and remain cool. For example, the cooling fins at the back of a refrigerator. They are usually painted a black color with a matte finish, so the fans can emit infrared quickly to keep the refrigerator cool.
So now we want to know how the heat can be transferred when we using the campfire. So the campfire is emitting heat through all three modes, which is conduction, convection, and radiation. Since air is a poor thermal conductor, you will receive much heat from the campfire via conduction unless you stick your hand in the fire. Therefore, assuming you are sitting several feet away from the campfire, we can ignore conduction heat transfer. The terminal radiation from the fire spreads out in all directions and is able to reach you. This thermal radiation is mostly in the form in infrared waves and visible light. In contrast, the campfire heat transfer via convection shoots straight up in the sky and never reaches you. Therefore, when you are sitting beside a campfire, almost 100% of the heat that you receive from the fire is transferred through thermal radiation. This is why the side of your body facing the fire gets hot while the side facing away from the fire stays cold. Thermal radiation is a form of light, and light travels out in straight lines. The side of your body facing away from the fire is literally in shadow and cannot receive the thermal radiation. So you can see that heat transfer happen all around us. You may not see it, but it does happen, direct impact on our life. So that's all from us about the presentation about the radiation. So bye-bye.
Thank you. Radiation is a kind of heat transfer that other than conduction and convection. Before conducting the experiment, we must know the safety precaution before conducting the experiment. The first thing of safety precaution is the equipment must have visible warning design. Besides that, we must conducting the device test for all radiation producing equipment. Furthermore, we must increase the distance of contact with radioactive device and materials. Moreover, we must protect ourselves by wearing appropriate PPE. And lastly, do not eat, drink, smoke, or apply makeup near the area where unsafe radiation substances were handled.
So, for the procedure, first of all, connect the plug to the power supply. Then, turn the power control knob on the control panel fully anti-clockwise. Before that, make sure your heater has been connected to the socket on the control panel. After that, move the radiometer until the distance was at 60 cm. Then, record the radiometer reading after 3 minutes. This is to allow the radiometer reading to stabilize. Lastly, repeat the experiment for distance 50 cm, 40 cm, 30 cm, 20 cm, and 10 cm.
Hello, today I will discuss about the result from the experiment radiation. For the distance x, the result takes every 100 mm, which is start from 100 mm until 600 mm. For radiometer reading y, you need to make a 3 cycle to complete the table. For radiometer reading y, you must have a 3 result. Repeat the step for 3 times to get the average of radiometer reading R. Next, for radiometer reading R, calculate the average of radiometer reading 1, which is 0.181 plus 0.183 plus 0.173 divided by 3. So you get the radiometer reading R, which is 1800. Next, for the log 10, log 10 means log for distance x is calculated by log 100 until log 600. For log R, calculate log for radiometer reading R at distance 100 mm until 600 mm. Finally, conclude the result in a graph. Plot the graph. Plot the graph log R and versus log X in Excel. Thank you.
Okay, so I'll be here to explain about the discussion of the experiment. So the main objective of this experiment is to prove that the tile intensity of radiation on a surface is inversely proportional to the square of the distance of the surface from the radiation source. As for the information, radiation heat transfer is the process which its thermal energy is exchanged between two surfaces obeying the law of electromagnetic. For this experiment, the temperature was set to the maximum point. The reading would be taken by a radiometer that measured the intensity of radiation on a surface. Radiometers are passive systems that receive and measure the radiation emanating and reflecting from objects of interest. The graph that was plotted from this experiment was a linear graph. The linear graph proved that we had achieved our objective. The graph shows that the distance of the radiometer is inversely proportional to the radiometer reading as the reading decreased rapidly from 3.2553 to 2.7559. It also showed that it followed the inverse square law. Inverse square law stated that a specified physical quantity or intensity is inversely proportional to the square of the distance from the source of that physical quantity.
In a conclusion, radiation is a kind of heat transfer other than conduction and convection. The radiation heat transfer is equipment that used to transfer heat from heat sources to plate by electromagnetic wave. It also used to verify the inverse square law for heat. The objective of this experiment is to show that the intensity of radiation on a surface is inversely proportional to the square of the distance of the surface from radiation sources. When the distance of the plate far from the radiation sources, the rate of heat transfer decreases. Hence, the objective of this experiment was achieved.